So what we're interested in is understanding how people process numbers when these numbers are important for certain decisions. Let me give just some examples. When buy a used car, for example, we might want to look at the odometer reading, so how many miles a car has, because this is going to be important for the price we want to pay for this car. Think about a university making admission decisions based on the results of standardized tests, or a doctor making treatment decisions based on the results of blood tests, or the weight of a premature baby, for example, or investors looking at the bottom line, so the revenues of a company when making investment decisions. In particular, we wanted to see whether people look at the numbers and process the numbers in full, or they just look at salient aspects of these numbers. Say the leftmost digit bias is sort of processed in full, but the other digits of maybe along complex numbers are not taken into account, or not as much as the first digit, and what the implications are, what the economic implications are of these potential biases. So we went and collected data on about 22 million used car transactions at used car auctions. So a pretty sort of large stake and large market to consider. And in fact, we wanted to see whether the price of these cars, all else equal, so trying to control for the characteristics of the cars and so on, so as to get to sort of a causal relationship, whether the odometer reading was processed in full in the price of these cars. We did indeed find that people, even sophisticated buyers, as in the case of used car wholesale auctions, don't seem to fully consider the odometer mileage readings. In particular, if two identical cars are on two sides of a 10,000 mile mark, say a car has 79,500 miles and the other has just right above 80,000 miles, then we find that on average the car below the threshold sells for between $150 and $200 more. Just to give a comparison, for cars with different mileage but within a given 10,000 mile interval, say between 77,200 and 78,200 miles, the difference is about $10 to $20. So there is a much greater and more discontinuous drop in prices. Interestingly enough, some of the agents, of the operators in this market, seem to be savvy to this potential bias. And in fact, we see that the supply of cars, so how many cars are brought to auctions, goes up right before these 10,000 miles mark. What we found particularly interesting is that we can expect people to be a little inattentive or just look at salient features of a number when stakes are low. So if someone costs 3.99 cents, we can think of it as $3 rather than almost $4. But we were interested in the fact that this bias persists even when large stakes are involved. We're talking about buying a car. Cars are expensive. And even when there is a market, a pretty well-functioning market, and so we might expect that market forces should select out any behavior that is not fully rational. And instead, we do find that even in this context, so a pretty demanding context to look for psychological biases and therefore behavioral biases, still remains and is pretty stable.